You ever stop and wonder what's your morning coffee, a giant steam engine, and, the stars in the night sky all have in common? Well, they're all playing by the same powerful set of rules, thermodynamics. So yeah, let's dive into this amazing world of energy.
But that's the big question, isn't it? When we say we study energy, what does that actually mean? It's not just one simple thing. It's a lot more complex and honestly way more interesting. So are there different ways to look at it? You bet.
4. That's the magic number. There are 4 fundamental branches. You can think of them as 4 distinct pillars that hold up our entire understanding of energy, heat, and work. And each one gives us a totally unique and powerful lens to see the world.
All right, so let's start with the OG, the one that really kicked this whole thing off, the classical branch. I mean, this is the stuff of legends. This is the science that literally powered the Industrial Revolution, all built on the raw power of steam engines and pistons.
Okay, so the really crucial word here is macroscopic. Classical thermodynamics is all about the big picture. It does not care about individual atoms or molecules. Not at all. It's all about things we can actually see and measure, right? Like the pressure in a boiler or the temperature of a room. It sees the whole forest, not the tiny little trees.
So, if classical is looking at the whole forest, our next pillar, well, it pulls out a magnifying glass. Let's talk about the statistical branch, which is all about counting those individual trees. This is where we zoom way in.
You see, this branch is the one that asks the big question, why? Why does a gas actually push against the walls of its container? Well, it's because there are trillions and trillions of invisible molecules doing this chaotic dance, just smashing into the walls over and over. Statistical thermodynamics is the beautiful math that connects that microscopic chaos to the stable, predictable world we can actually see and measure.
And this right here, this is where it all just clicks. These 2 pillars, they aren't fighting each other. They are 2 sides of the exact same coin. Classical tells you what is happening. You see that pressure gauge go up. But statistical tells you why it's happening by revealing this secret world of particles that makes it all work. One describes the forest, the other one explains it by getting to know every single tree.
Okay, so our third pillar takes all these fundamental ideas and points them at one of the most transformative fields in all of science, chemistry.
What's so cool about this branch is just how practical it is. I mean, think about it. Is a certain chemical reaction even possible? If it is, how much energy is it going to release? Is it going to create something useful? Chemical thermodynamics is what gives us those answers. It's the science behind everything from the battery in your phone to the combustion happening inside your car's engine.
And that brings us to our 4th and final pillar. After all this talk about change and reactions and particles crashing around, this one is about the exact opposite. It's about what happens when everything just settles.
Oh, I love this one. You can think of it as the Zen of thermodynamics. It describes the final, calm, stable state of a system. You know that hot cup of coffee on your desk? As it cools down to match the room temperature, it's actually moving towards thermal equilibrium. This branch focuses only on that final destination, that state of perfect balance where, on a large scale, the show's basically over.
So there we have it, 4 totally distinct branches, 4 different ways of looking at the universe. But here's the most important part. They are not separate competing ideas at all. They're a unified toolkit, a complete set of lenses for understanding how energy shapes literally everything around us.
So let's just put it all together one last time, right? Classical gives us that big picture view. Statistical zooms way in to explain the why behind that picture. Chemical applies all of those rules to the reactions that build our world. And finally, equilibrium describes where everything is headed in the end, to a state of perfect balance. 4 pillars, 1 incredible science.
So here's a final thought to leave you with. As you go about your day, just look at the world around you. Which of these pillars is holding it all together? Well, the answer, of course, is all of them. They are working together, invisibly, in every single moment. Thanks for watching.